thanks for selecting us as an finalist here. And so we are Soletair Power. I'm Petri Laakso, the CEO at the company. So we want to convert buildings into CO2 capturing machines. We do that by capturing CO2 from building ventilation so that we can make people perform better. And also we can turn that captured CO2 into something useful like fuels, or turn it into concrete, and so on. Next slide, please. Company is founded in 2016. There are 17 employees at the moment. We are based here in Finland, Lappeenranta. And so we contribute to reducing emissions in buildings by capturing carbon from the ventilation system. Next slide, please. Everybody knows that the CO2 level in the atmosphere is getting higher and higher, and that's why we think that there needs to be negative emissions, so that you need to remove the CO2 from the air, not just by limiting a smokestack. Of course, it's a good way to kind of slow down the climate change, but we think that you should do negative emissions. And by doing that, you can really turn the course of climate change. And next slide, please. If we look at how the CO2 affects us people, it affects the nature, but it also affects us people. And here's one study from US, that if the outdoor CO2 level doubles to 800 ppm, which easily happens in buildings and offices, we will lose like 20% of our cognitive function. And since we spend most of our time in buildings, we think that the CO2 level lowering in buildings would be a good thing for people performance. Next slide, please. So we do this in buildings and in building ventilation. And if customer wants, we can turn that CO2 into fuels like we did in the Dubai World Expo this year. And this way we can increase people performance, do those negative emissions in buildings. So we can really make a building act as a carbon sink in let's say net way. And yes, next slide, please. Here we can see an installation. On left, there is the metallic looking box, is the ventilation machine close by a building here in Finland. And on the lower left side, the air is entering the ventilation system, and it doesn't matter what is the temperature outside, whether it's +40 or -50 or something. After the ventilation unit, it's typically 20 plus something, and it's really good for the carbon capture and before the air goes into the building. On the top side of the picture, we can see an exhaust pipe or duct from which the air escapes the building. If you capture the CO2 from that duct, you can maximize the CO2 capture, but you don't do the people benefit. If you do the recirculation channel CO2 capture, then you can do both in the same building. Next slide, please. If you have a single room system, what we can also offer, you can really keep the CO2 levels low. Here is one example from a single meeting room. This is from a building which was built 2006, so fairly modern. So we can really keep it like below 600 ppm, even though without the system, even though the ventilation is running, it would go to 1,200. So this is really a big difference, and you can really feel the change if you have a system at your office. Next slide, please. Of course, the reporting is a vital part of our business, because the customers want to know that is the system running, because the service is kind of in the air. And when they are running the system, so we can report how many kilos of CO2 was kind of captured from the air and how it affects the indoor air. Next slide, please. If you take a big city like Tokyo, if you make a really wide-scale deployment of our technology from all the commercial real estate in Tokyo, we can capture like 6.5 million tons of CO2 per day from the ventilation that is already running. So it makes really a difference. And it's our normal, if you take it from a normal ventilation, you can capture as much of CO2, or which is equal to half of the building's CO2 emissions in the operational lifetime. And we can sell this as a service or as an investment to the building. Next slide, please. Some details about the one ventilation unit, or let's say here is a 5 ventilation units. So if you put it in a building, typically one unit is like close to 20,000 square foot, and if you have 5 of those, you can capture like 6,000 kilos of CO2 or 5,500 in 1 month, which is equal to 6 acres of forest in 1 year, sequestrating carbon. Next slide, please. So those 2 business models. First one is, of course, investment. Since we are a startup, it's easier for us to just sell the units. But then the next is that we can sell this as a service, so that the building tenants can take an advantage on the best indoor air for their employees. The cost is like $1 to $2 a day per employee. Next slide, please. There are, of course, other companies capturing carbon or CO2 directly from air, but they are mainly focusing on outdoor large-scale capture, and we are doing this in buildings. Next slide, please. 4 different product categories. First one, the building HVAC connected device. Second one is the outdoor CO2 capture. Third one is the single room problem solver, and the fourth one is the power to X unit that you can really capture CO2 and make fuels out of that. Next slide, please. So we have 7 patents. This one was granted to us in December last year in US. Next slide, please. A huge market, completely new one though, but there's a lot of real estate out there that we can make like a system that is used in every building in the future when the CO2 level is higher. Next one, please. So there's some traction that we've made over the years, and several deliveries. Latest one to Germany. Next one is going to Danish customer, and last year we had a delivery in Dubai. Next slide, please. Team has a really long experience from different startups. Biggest exit 120 million to Visedo, to Danfoss, and we think that we are the best team to make it happen. Next slide, please. So what we are now looking for is a Series A funding, and for this we can get a 24-month runway to work on the CO2 capture solution for buildings. Next slide, please. So thank you. I guess I used my time already.